Welcome to the DIY Honda Garage channel. The DTC P2720 indicates a pressure control solenoid D control circuit low issue, specifically in the Honda Civic models from 2011 to 2015. This particular error is related to the electrical circuit, specifically implicating a breakdown in communication, rather than a mechanical issue within the transmission system. It's crucial for the vehicle's engine and transmission to communicate effectively to manage power efficiently. The pressure control solenoid plays a pivotal role in regulating transmission fluid pressure, which in turn affects the shifting quality and overall performance of the continuously variable transmission, CVT. When a problem is detected with this solenoid's control circuit, it can lead to ineffective transmission operation. DTC P2720 typically manifests due to electrical failures, and understanding the circuit's layout and connections is essential for proper diagnosis and repair. DTC P2720 concerns the pressure control solenoid D, which is integral to managing the pressure in the transmission. This solenoid is located within the continuously variable transmission assembly, typically integrated into the valve body. Its role is to modulate hydraulic pressure, which directly influences how the vehicle shifts gears. The electrical circuit is vital as it communicates operational commands to this solenoid from the powertrain control module, or PCM. An issue in this circuit signifies a failure in either the communication link or the solenoid's function, highlighting the need for a thorough investigation of wiring and connections. Precise voltage levels must be maintained for effective transmission operation, and any discrepancies can lead to erratic shifting or complete transmission failure. Several potential causes are associated with DTC P2720. A blown fuse in the circuit can interrupt the flow of electricity, directly impacting the solenoid's ability to function correctly. If the IG1 MSOL wire experiences an open circuit, it can lead to inadequate signaling to the solenoid, causing the control and operations to fail. Additionally, a malfunction within the solenoid valve itself, often due to wear or internal failure, can also trigger this error code. Each of these issues must be carefully diagnosed to isolate the faulty component. The troubleshooting process will generally start with reviewing electrical connections and continuity tests, as these initial steps can often reveal the source of failure without extensive disassembly or component replacement. Potential symptoms associated with the DTC P2720 may arise in various forms. Drivers may notice erratic shifting behavior, where the transmission struggles to shift smoothly between gears, especially during acceleration. Another significant symptom could be transmission overheating, which may occur if the system attempts to compensate for the pressure control issue. The check engine light being illuminated usually alerts the driver to any underlying faults detected by the vehicle's onboard diagnostics, including the DTC P2720. Recognizing these symptoms early on is paramount, as prolonged issues can lead to further damage to the transmission system and may necessitate costly repairs. Monitoring performance and being alert to changes in driving behavior can guide timely repairs. Initially, it is crucial to verify the problem when diagnosing DTC P2720. Start by turning the ignition switch to the on position or pressing the start button to enter on mode. Following this, clear the DTC using the Honda Diagnostics System, HDS, to reset any previous data that may distort the current readout. Start the engine and allow it to idle for at least 1 second before rechecking for any pending or confirmed DTCs with the HDS. If DTC P2720 is indicated upon this check, it confirms that the failure is persistent, necessitating further action and troubleshooting steps. Conversely, if it does not appear, It may indicate an intermittent failure, and you should refer to any recorded freeze data for diagnostic insight, possibly attempting to reproduce the issue under those specific conditions. For the second troubleshooting step, focus on the IG1 MIS-SOL line. Begin by placing the vehicle in the off lock mode to ensure safety. Utilize the HDS to jump the SCS line, leading to a brief waiting period of over 1 minute. Next, disconnect the PCM connector A, 51P, to isolate it from any electrical feedback. Turn the vehicle to the on mode and measure the voltage between the prescribed test points. PCM connector A, number 1, and body ground. If you find battery voltage present at these points, it indicates that the IG1 MIS-SOL wire functions properly, allowing you to progress to step 3. If not, inspect the under-dash fuse relay box for a blown fuse, replacing it if necessary. If the fuse continues to blow, repairs must focus on locating a short circuit. If the fuse is intact, the problem could lie within the IG1 MIS-SOL wire leading up to the PCM. In step 3 of troubleshooting DTC P2720, you need to ascertain whether the CVT lockup clutch control solenoid valve operates correctly. This can be accomplished by conducting a practical test of the solenoid valve. If it is functioning as expected, you will then transition on to step 4. If the solenoid does not work properly, further diagnostics will be required to identify the malfunction. Understanding the proper operation of this clutch control solenoid is essential because it influences the efficiency and responsiveness of the vehicle's transmission. If issues arise here, it can lead to further complications either in the lockup function of the CVT or erratic shifting behaviors. The results from this step will direct you to either proceed with further electrical checks or possibly tackle actual component replacements depending on functionality. Step 4 involves checking for continuity in the LCC-LS line, critical for determining if the transmission is communicating correctly with the PCM. Begin by ensuring the ignition switch is in the off mode. Repeat the procedure of jumping the SCS line with the HDS and proceed to disconnect the required connectors, the solenoid wire harness 8P and PCM connector B, 51P. You will measure for continuity between the designated test points, ensuring that the circuit connecting the solenoid and PCM is intact. You will need to check from the solenoid wire harness, wire number 8, to PCM connector B, wire number 4, under the condition that the ignition is off. If continuity is confirmed, this indicates the LCC-LS wire is operating correctly. If not, you will need to repair any identified openings in the wire to restore proper function. In the final troubleshooting step, focus on checking the CVT lockup clutch control solenoid valve for electrical specifications. Begin by removing the solenoid wire harness before disconnecting the CVT lockup clutch control solenoid valve 2P connector. The goal here is to measure the resistance between test points specified in the diagnostic procedure under the condition that the ignition is off. You are looking for a resistance reading between 4.9 and 6.6 ohms, indicating that the solenoid itself is functioning correctly. If the solenoid falls within this range, the next step will be to replace the solenoid wire harness, as it may have sustained damage elsewhere in the circuit. However, if the resistance does not meet standards, this suggests a faulty solenoid valve, necessitating the replacement of the valve body to rectify the identified issue and restore optimal transmission functionality. After completing all necessary repairs associated with DTC P2720, it's essential to perform a final verification to ensure everything is working as intended. Undertake a test drive to observe the vehicle under various driving conditions and ascertain that no further erratic shifting or transmission issues are present. Use the HDS to verify that the previously logged DTC has been cleared from the system without re-emerging during the test drive. Monitoring transmission behavior during this period is crucial, as it can reveal if the repairs made effectively resolved the underlying issues. This phase serves as a conclusive check to reaffirm all systems are functioning optimally. If any issues persist, further diagnostics may be required to ensure all components are in working order. To prevent the recurrence of DTC P2720, it is advisable to institute regular preventive maintenance strategies. Begin by routinely inspecting all necessary electrical circuits, especially those associated with the transmission system, to detect any wear or potential issues before they cause breakdowns. Ensure that transmission fluid levels are maintained according to manufacturer specifications, as inadequate fluid can lead to overheating and erratic behavior. Regular checks on solenoid functionality can help identify any early signs of failure, allowing for proactive rather than reactive measures. By implementing these practices, vehicle owners can significantly mitigate risks associated with transmission failures and enhance the overall durability of the Honda Civics transmission system. These proactive steps contribute to maintaining efficient operation and can help prolong the life of the vehicle. In conclusion, DTC P2720 highlights a significant concern regarding the pressure control solenoid D and its control circuit within the Honda Civic from 2011 to 2015. The core of the troubleshooting revolves around thoroughly examining electrical components and ensuring the integrity of connections. Understanding how to trace circuit problems critically impacts resolving this issue effectively, narrowing down to specific wires or solenoids that may be faulty. Each step of the diagnostic procedure is designed to isolate the problem, ensuring that any failure in the system is comprehensively addressed. Ultimately, by following these guidelines and ensuring preventive maintenance, vehicle owners can maintain transmission reliability and performance, enhancing their driving experience. Please like and subscribe to the channel. See you next time.